In my last video, I made a custom ball screw from scratch because I wanted one that would fit into a confined space. In particular, the nut needed to be a lot shorter than any standard ones that are available. Several people commented, why didn't I just chop off the end of one of the ball nuts I already had and use that instead, saving myself a lot of work? Well, there's a very good reason I didn't do that. Because I didn't think of it. Because I didn't have one the right size. The ball screws I had were all 16mm diameter, which is a very common size. The screw that I made was only 10mm diameter. This is because, due to the design of the actuator, the screw needs to be able to fit inside the piston rod as it retracts. The piston rod itself is 16mm diameter. Any bigger would look out of place, so obviously a 16mm screw isn't going to fit. Of course, there are smaller ball screws available. I have a machine that's fitted with 8mm screws, though this size is very hard to find and also quite expensive. I couldn't actually find any 10mm screws for some reason, but 12mm is a widely available size, so I bought this one to experiment with. This means I'll have to bore out the piston rod to a larger diameter, reducing its wall thickness, but it should still be strong enough. This is just a cheap eBay screw, not a brand name one, but the quality looks good, and it appears to be the same design as the bigger ones with 3 circuits of balls. Before I modify this, how good is it? I have the screw clamped in my lathe with tailstock support. I also clamped a bar to the side of the nut to stop it from rotating during this test. In the axial direction, which is usually the most important, the backlash is around 0.03mm, which is pretty good. That's less than half of the one I made myself. Just to show there's no flex in the setup here, with the stylus on the end of the screw, there is no movement. In the radial direction, there's a little more backlash, though there's also some slight flex in the screw in this direction, making it seem worse. And rocking the nut gives a similar figure. One last thing I want to check is that the outside surface of the nut is actually concentric with the thread, which it does appear to be. Here's something that normally you never want to do to a ball screw. I was actually expecting all the balls to fall out, but since this is a new screw and well greased, they all stayed inside the nut, but not necessarily in the right place. Some appear to have moved, so trying to put the screw back in now would likely break something. The way this nut is made is slightly different to mine. There is one thread ground all the way through it. Then there are these 3 plastic ball diverters, which provide a return path for the balls. Each circuit is only just under 1 turn. Each end of the nut has quite a deep recess for the seal. These stop dirt getting in and help keep the lubrication in place. I won't be needing these as my screw and nut will be fully enclosed. They just take up extra space since the nut has no threads in these areas. The nut is made from very hard steel. Not even carbide tooling can cut it. There's really only two ways to do it. I can either heat it to soften the steel, but then I'd lose the main advantage of using a commercial ball nut. Trying to re-harden it after machining might cause it to warp and become useless. The second way is less sophisticated. Actually, there is also a third way. But that's really somebody else's area of expertise. So it's going to have to be the grinder. This has left a nasty, uneven edge. But fortunately, the localized heat from grinding has softened it enough that I'm now able to turn it on the lathe to clean it up. Originally, I'd planned to use this part of the nut and remove the recessed end, leaving only the one circuit of balls I need. But there's really not much to attach anything to. I can't drill and tap it. I'd have to make some sort of collar to clamp around it. The other end does have this convenient flange to attach things to, but the overall length is going to be too long. I wonder. This is asking a lot, as it's hardened steel and also an interrupted cut. I didn't get far. And this insert is now ruined. But grinding worked before, so I've only removed 1 millimeter or so, but the heat will have softened the flange without affecting the threaded part of the nut. So now with a fresh insert, I'm able to turn down the flange until the whole nut is short enough. It's now actually shorter than the one I made from scratch. Before reassembling the nut, I made sure to clean out all of the chips and grinding dust. Then, with the aid of some grease, I was able to get the balls back in. This is a lot easier when there's only one circuit, as any in the wrong place will just fall out and not become trapped. This ball that got pushed out would have ended up between two of the circuits, and when load is applied to the screw would probably have destroyed the plastic ball diverter. The screw feels just as smooth or even smoother than before, and will even drive itself under its own weight. Though I've also removed the seals, which probably helps. So, with the same measuring setup I used initially, how have these modifications affected the screw? As you might expect, with only one circuit, there is quite a lot more rock of the nut. Measured at the edge of the flange, it's quite extreme. But measured in a similar location to before, it's not much different. And as I said before, the nut will be constrained in this direction, so not able to rock like this. The axial and radial backlash have both increased, but but not significantly, only about 1/100th of a millimetre or two. So, having carried out this usually totally unnecessary ball screw modification 2 different ways now, which do I think is best? I did like the flexibility of making my own screw and being able to design it exactly to suit my application, but I have to admit it was a lot more work and won't be as durable as a commercial screw. Modifying an existing ball nut was actually easier than I had thought, not without its challenges. I wasn't sure if it was even going to be possible, but the result is certainly good enough for what I want to do.